Hello folks, in this video tutorial I'm going to demonstrate how to run correlation in SPSS, which is Pearson's correlation. We can also be referred to as Pearson's product moment correlation coefficient. In this demonstration I'm going to assess possible linear relationship between two variables which are continuous variables. In other words, I'm going to assess a possible linear relationship between two quantitative variables based on the assumption that both variables are normally distributed and are not affected by extreme values, which means are not inflated or dampen the strength of the relationship. What I'm trying to say is that both variables should be normally distributed and not affected by extreme value in such a case that can dampen the strength of the relationship. So to begin with, one needs to specify the hypothesis. For example, the null hypothesis could be that the two variables are independent. Then one could also specify the alternative hypothesis as the two variables are dependent. Having said that, it is highly imperative for one to be able to interpret correlation results. So that brings us to knowing how the correlation coefficient works as far as interpreting the results is concerned. So we've got what we call positive correlation. The relationship between two variables could be termed positive if both variable increase or decrease at the same time. So if both variables are increasing at the same time, a variable A increasing as well as variable B increasing, then we can call it a positive correlation. So based on a correlation coefficient, a correlation coefficient close to +1 indicates a strong positive correlation. So given the correlation coefficient of between +1 and -1, so it ranges, the coefficient ranges from +1 to -1. So a correlation coefficient that is close to +1 indicates a strong positive correlation. In the same vein, the relationship between two variables could be negative correlation in the sense that if the amount of one variable increases and the other decreases, or vice versa, one could term it as a negative correlation. Similarly, a correlation coefficient close to 1 indicates a strong negative correlation. There could be instances as well where there could be no correlation, which indicates no relationship between the two variables. So in that case, correlation coefficient could be zero, which indicates no correlation. So this relationship can be visualized graphically, as you could notice here. Based on this representation, it shows a positive correlation, which means that both variable increases or decreases at the same time. For example, if this is representing variable A, this one variable B, or you may say variable Y or X. If Y is increasing, the variable, the corresponding variable X increases as well. So, yeah, that is what we mean by positive correlation. This is negative as the amount of one variable increases, the other one decreases, as you could see here, right? Then this third one here, there is no correlation. So that is how it can be seen, visualized in a graphical form. So at this point, I'm going to use a data set to run a Pearson correlation in SPSS. I'm going to demonstrate how to run that process in SPSS. Suppose we are interested in the correlation between the birth weight of babies and gestation in weeks, which means I'm going to use a data set that contains birth weight of babies born to different mothers, where you have mothers that are smokers and mothers that are non-smoker. So what I'm going to do at this point in time, I'm going to upload a data set in SPSS. All right, let's go. IBM. Right. Oh, yes, gonna take a while. Okay, right. We are going to use. Okay, let me open a new one. I hope it's not already in existence. We have it here. Okay, right. Now, new data set. Open it. A data set. Right. I'm going to use. Okay, the birth rate. Okay, right. Now I'm going to make use of this data set to demonstrate how to run a Pearson's correlation in SPSS. Right. As you could see, given the variable views, these are the variables as far as this data set is concerned. You've got the ID of the baby, the head circumference, the length of the baby, the birth weight, the gestational age at birth, maternal age, then the maternal height. Okay, so Those are the variables, right? So what we need to do first of all, based on what we are going to do here, let me try to remind you what we're intending to do as far as this demonstration is concerned. We are going to correlate. We are interested in the correlation between the birth weight of babies and gestation in weeks, full sample, non-smokers, and smokers. So what we should realize here is that this is a data set that is we've got a non-smoker, a smoker, all incorporated in the same data set. So if we are to run a correlation, if we are to compare the two variables between birth weight of babies and gestation in weeks for the full sample. So it's very easy. I'm going to demonstrate to you how we need to run that process. So what we need to do is to produce, or what we need to do first of all is to produce a scatter plot for birth weight and gestation. So how do we do that? It's a simple process. I'm going to demonstrate it shortly. So what we need to do is you click on the graph, say chart builder, say okay, right. Then we're looking for scatter diagram. You move it to this place, to this box, the chart preview box. Then we're looking for the two variables that we want to compare the relationship. Don't forget the two variables are birth weight and the gestation in weeks. So what you need to do is a simple process. Now you look for the variable birth weight, then push it down here under the gestation period. The gestation period, right? Then put here. Then the next thing is to click OK. Then you see the pattern, right? So as you could see here, there's a positive relationship between the birth weight and the gestational period at birth, as you could see the pattern now, right? As the gestational age increases, so the birth weight increases as well. So that is what the relationship shows. It shows a positive relationship, as you could see there. Now, to produce a scatter diagram. Okay, what another thing that one needs to explain here is, as you produce the scatter diagram now, there are certain features that you want to be added, to the diagram, for example, the title and whatever. So it can be done. You can add it, should label, and all those type of stuff. Right. Okay, that is that. Right. Okay. Now, the next thing is to try to run a correlation between the gestational period and the birth weight of babies born to smokers, mother, or smoking mothers and non-smoking mothers. So, given the data set that is before us, is a composite data set. So, what we need to do in order for us to be able to sort out the data set for the smoking mother, we need to we need to select the cases for the smoking mother as well as the non-smoking mother. So, how do we do that? As we said, this one is the full data set. So, we need to select the case for the non-smoker and the, the non-smoking mother as well as the smoking mother. So, what do we do in order to be able to achieve that? You click on the data, you say select case, right? Then you click on if condition is satisfied. Let me show it to you clearly in the PowerPoint presentation. It's clearly demonstrated on the PowerPoint presentation as well. Okay, that slide is not included here. Okay, let's continue. Right. So, what we need to do in this case, we click birth weight, then you say for smoking mother, you've got a value that has been attached for that. Let me show it to you clearly so that you know what we're talking about. Right. So for smokers, you have it's a categorical variable in short. Then you have 0 for non-smoker, 1 for smoker. Okay, let's try to create a data set for smoker or smoking mother. Then we could select the case in this nature and you say select cases. Right. Then you click if this icon, if conditions is satisfied. Then you click here. You say birth weight. Then you said you try to say 1. Then you click OK. Here we need to copy selected cases in a new data set. Here we can give it a name. For example, we can say smoking, smoking mothers, smoking mothers, right? And you click OK. Data set, copy data set. OK. Smoking mother. The name of the data set is not valid. Okay. The name is not valid. You should make sure that you follow the rules. Okay, good. Now you can call it small class. Call it small class. Right. Okay. Now we've created data set for the small class. Okay. Now let's try to run the correlation. Then it's the same process. It's very easy. Graph, chart builder, and you click OK. Then we want to run a scatter diagram. Right. Then that's it. Then the bet width. Click. Then the gestational age. Right. Okay. Then right. To take us to the output, we can click here. Okay. Right. It's very slow. It's very slow. Okay. Right. Now, let's create a data set for non-smoker. It's the same process. You click select cases, satisfied, then net weight equals 0. Then you click here, then you copy selected cases to a new data set. We say non-smokers. Non-smokers. Right. Now we've created, as you could see here, the title bar, we created a new data set for non-smoker. Then we can exploit through the scatter diagram. Same process, right? Here we go. Then bet weight and gestational period. Right. You click OK. Right. The machine is the process is very slow. It's very slow to give us the output. It's very slow. Very slow. It's freezing here. Okay. Right. The machine is the laptop is taking its own time. Yeah. Otherwise, we are going to have something of this nature, right? So the next process now is to run the correlation, yeah, to run the Pearson correlation in SPSS. So in the same vein, we're gonna run for the full, and the full means where both participants are combined. That means smoking mothers and the non-smoking mother. Then we have to run another one separately based on smoking mothers as well as non-smoking mothers. Right. So that is what we are going to do now. So what we need to do, I hope my laptop is still in order. Okay, this one is the one for the full. So how do you run the correlation in SPSS? Click on this, go to say correlate, right, by variance. So what are we trying to find out? Which variables are we trying to find out the relationship? Or what variables are we interested? We are interested in which variables? Again, we're interested in the birth rate and the gestational age. We want to compare the relationship, whether it's positively correlated or negatively, or perhaps if there is correlation or no correlation. So now we need to do that. Right? Good. Say continue. Here you click this Pearson correlation to tail. Right? Then you click OK. I hope we are able to see the output now because the machine is getting frozen. Okay. All right. As you could see here, you see this is a level of significance of 0,001. This is a coefficient 0.0708, which means they are positively correlated. Okay, now let's go to the PowerPoint presentation. Right, so this is the one we've done now, right? For the full, for the full sample, the results show that there is a positive correlation between the gestational age and the birth weight. As you could see, the coefficient is 0,708 and the p-value is uh, less than 0,01. So this indicates that the gestation age increases, then the birth weight also increases, as we've seen when we were exploring the data based on the scatter diagram. So we can as well do for the smoking model as well as uh, the non-smoking model. Okay, this one is the data set for the smoking model. Okay, let's try to run the regression as well. Not regression. Let's try to run the correlation as well. Then a variant, uh, we're interested in the birth weight as well as the gestation. We're comparing it to find out the relationship. We've done to compare the relationship between the two variables, gestational age and birth weight of babies born to parents, to mothers. So we can as well do the same for non-smokers as well as smokers. So it's the same process. What we need to do is to go to SPSS and open the data for or the data set for uh, smoking mothers. Let's first of all start with that of smoking mothers. So what you need to do, you click on the file, then you said also click on open, say data, then luckily we've got a separate data set for smoking mothers, right? Then you click it. Here we go. Here you can see the data set for the smoking models. Yeah, this is the variable view, this is the data view. So at this point in time, what we need to do or what is important for us to do is about comparing the relationship between the two variables. So in order to do that, it's very simple. So what you need to do is you click on analyze, the icon analyze, then you scroll down and go down to this icon or this command, which is bivariant. Then you click on bivariant. Right. So the next thing is you will see a pop-up window. So what do you do to that pop-up window? So you need to move the variable from the left, the trusted variable, to the right. So what are the trusted variable here? Is the variables are birth weight as well as gestational age at birth. So this is how to move the variables. Right. Now, the variables have been moved to the variable box. So you must make sure that you select the right option. So what we do here is Pearson's correlation coefficient. So you must make sure that it's checked. Then the box is checked. So we're doing a two-tier test. So what you need to do afterwards, you need to click on the OK button. Say OK. Now it will take you directly to the output window. Now let's see what we have in terms of the result. As you could see here, we have 0.751. This shows the coefficient, the correlation coefficient of 0.751. So what it means is this: there is a positive correlation between the two variables. Which are the variables again? Birth weight and the gestational age and birth of children born to smoking mothers. So let's look at the p-value. The p-value is 0.001, which means it's significant. It's less than 0.05. So we can uh, confidently say, based on the data, the information before us, or we can say based on the result before us, that there is a positive correlation between the variables. So now that we've done for the smoking mothers, let's try to uh, do the same thing using the same variable of birth weight and, uh, and gestational age at birth for uh, children born to non-smoking mother and see how the relationship is going to take place, whether it's going to be positive or negative, right? So to do that is a simple process, just like we've done before. What we need to do again, we need to load or open the data set for the non-smoking mothers. Right. So it's a quick and easy process. Now we've got a different data set for non-smoking mothers. So here we go. Click it, right? It's open here. As you could see, on the title bar is written no smoking mothers, right? That means we've got the right data set. So the next thing we need to do now is to run the correlation. So it's a simple process, as you've seen before. I'm going to demonstrate it now. So what you need to do is to click on the icon Analyze. Then you scroll down to correlate. Then you come to this command, right? You say click on bivariant. At the same time, you need to move the two interested variable to the variable box here. So where are the variables here? So the birth weight as well as gestational age. Then move it. You move the variables. The next thing is to make sure that this box is checked Pearson because we are running a Pearson uh, correlation. Then the next thing is you click OK. Here we go. Now it has taken us to the output window. So what do we have now in the output window? Here we have the result, which shows the correlation, the coefficient as well as the p-value, right? So based on the result, we have a coefficient of 0, 695, which is as well a positive relationship between the two variables. And the p-value here is 0.01, which is the same. So based on the results, we can confidently say that there is a positive relationship between the birth weight and the gestational age at birth of babies born to non-smoking mother. So, thank you for watching my video.